Morning students, in yesterday class we discussed about the simple harmonic motion, the definition of simple harmonic motion, and another one is the equation of that here, displacement of simple harmonic motion. Today we have to discuss that geometrical representation of displacement of the simple harmonic motion. Or it is also a circular motion. Consider a circular motion here. I take a circular path here. Okay, first one, if the particle starts from its mean position, and at two extreme positions are there. Okay, the first one is here. If a particle starts from its mean position, means what is the displacement along y-axis and what is the displacement along x-axis. We have to check here. Okay. If a particle starts to oscillate or starts from its mean position, okay, starts from its mean position, okay, its mean position. After any instant of time, it means at any instant of time, what is the displacement of the particle and what is the displacement along x-axis and along y-axis instant of time. Okay, I will take the circular motion like this here, or oscillatory motion here. Consider the oscillatory motion. If it is a periodic motion or a circular motion of a particle, when this is called the origin or this is called the center of this circle, this is called the y-axis and this is called the x-axis. Here it is a positive x-axis, positive displacement is there along x-axis and positive displacement is there along y-axis. Call this displacement as a y, call this displacement as the x here. If the particle starts from its mean position, from here, it is from here. After a small instant of time, the particle is at here, okay? If the particle is at here, it is called x dash, y dash. Starts from x here. Then it starts to move from x to p position. Its position vector, call this vector as a nothing but an amplitude of that, the maximum displacement. I will take here the amplitude of that a. Resultant displacement of those two. Resultant displacement is a. If it makes a certain angle at here, that should be theta. That should be what? Theta. Or theta is equal to what happens? That theta is equal to omega into t. If it is theta, then if you draw the like this is also what? The opposite angles are equal to each other. Okay. Okay, like this. It means what? That theta is equal to omega t is there. Call this theta is equal to omega t, and this is called the y-axis here. It is the x displacement, and if it is y, this is also y. If it is x, this is also x here. We have to calculate. Very simple, but that one is y. Then what happened? From triangle, take here the triangle is here XPO. Okay, from triangle, that is XP or XOP something here. Okay, then according to that one, the trigonometric function sine of theta become what? Opposite side of theta. Opposite side of theta is nothing but what? Y. Divided by its hypotenuse is nothing but a. Then it becomes what? It becomes the y is a displacement. Y is equal to a into sine of theta, or the theta is equal to omega t. Then a into sine of omega into t is the displacement of the particle. or if it is the y displacement, or if it is the x displacement, x is there, x is nothing but the resultant of these two displacement is a here, the a is same here, it is the adjacent side, it is an adjacent side, its components is cos theta, then x component become the a cos theta, then here a into cos of omega t is there. If there is no any phase, it means the initial phase is 0 because it starts from its mean position. If it is starts from mean position, the initial phase considered as a 0 here. Its initial phase is 0. Oh, it is 0. Right? It is number 0. Phi naught is considered as a 0 here. Okay, one part is that if that particle starts from the extreme position, maybe positive or negative. Okay, if it is starts from its mean position, the theta should be with that particle and the x-axis. Theta should be here only. Okay. Second part is if a particle starts from extreme position, with some phase, with some initial phase phi naught. If it starts from the initial phase phi naught, that phase is nothing but it represents the position and direction of a particle with respect to its mean position here. We have to write this phase with respect to its mean position only. Okay, extreme position is different here. There are two conditions are there. Okay, I'll write the two conditions here. If it is starts from, okay, it is the y-axis, x-axis is there, x displacement and y displacement both are there here. If the particle it is at here, it means from mean position it is at here. But it starts from with certain phase with respect to the mean position. That phase should be, if it is here, we call this is a it is x dash, y and y dash is there. It is called the y displacement. It is called x displacement. X is there, y is there. The theta should be here only. But the particle starts from A to P. It is A to P. It means what? A to P. Here A makes with a certain angle here. That is called the initial phase. The A makes the certain angle, that is initial phase. What is the total angle? What is the total angle made by the particle up from A to P? That should be that omega t. It starts from here now, so it is omega t. This is the small angle with the x-axis. Theta is nothing but omega t, it is right. But we have to calculate the theta. We have to submit. It means we have to calculate the phase, total phase. It is not initial phase. We have to calculate the total phase. Here consider that theta as a total phase. Okay. Its equation becomes y is equals to whatever. Y is equals to A into sine of omega t is there, because here theta is equals to omega t because it starts from its mean position. But what about theta here? It is sine of theta. A is same. Theta at here means theta is nothing but what? Omega t minus of phi naught. In this situation, this theta is equal to omega t minus of phi naught. Just consider it is a minus because it starts from the negative axis. Negative y-axis, it starts from negative axis, it becomes what? Negative. This becomes negative, that's why it is minus. Okay? A into sine of omega t minus of phi is there. Or it is x. X is equal to what happened? A into cos of theta. This becomes A into cos of omega t minus of phi naught. Starts from the negative axis. That's why it is negative. Okay. Then, if the particle starts from the another point, another extreme position, if it is a positive. If it is positive there, okay? X-axis, y-axis, its particles displacement particle at the point P from the mean position. If it is the angle theta is there. If it is starts from an extreme position with some initial phase phi naught, that phi naught is now in the position, it is a positive axis. It means from here. If the particle starts from here, call this position as a. Total angle is theta. It makes certain angle, that is a phi naught, and it is covered with a certain angle. It is covered from A to P. It is moving from A to P with certain angle, that is omega t. Then what about theta? Okay, it is a y displacement of the particle. Okay, it is the x displacement of the particle. It is also y, it is also x here. Both are same. Then what happened? Here the y displacement is equal to A into sine of theta. But theta is nothing but it is the sum of omega t and phi naught. Here the theta is equal to omega t plus of phi naught. Very simple, because the particle starts from the positive axis. The positive axis means from above x, it is not positive, it is also positive here. Okay, then what happened? A into sine of omega t plus of phi naught. Then x is there. X is equals to A into cos of theta. Then here A into cos of omega t plus of phi naught is the equation of the particle which is starts from its main position and extreme positions are there. Okay, then we have to make the 2 points, very important points in this SHM, in this simple harmonic motion. We have to take, if the particle starts from its main position, we have to take the equation, that is y is equals to A sin omega t. If the particle starts from its main position, take the equation, that is y is equals to A sin omega t. If the particle starts from its extreme position, if it starts from extreme position, we take that x is equals to A cos omega t. Okay? Okay. Then I will remove this one. Okay. Now, I hope you understood this equation of displacement of the simple harmonic motion. Very important notes are there. I will write here. One is, very important note is there. If a particle oscillate from the mean position at any instant of time, the displacement is what is the displacement? displacement y is equals to a into sine omega t. Okay, consider this equation. When it starts from its mean position, so that. The second one is if a particle oscillate from extreme position, from extreme position at any instant of time, the displacement is x is equal to, using this equation, x is equal to a into cos of omega t. Sometimes you are using like this, sometimes it is at extreme position also we are using this equation, sometimes also using this equation. You can use any one. Okay, you can exchange these two. Okay. Then next thing is the velocity of a particle. Velocity is nothing but what? It is nothing but it is the rate of change of displacement of a particle which executing the simple harmonic motion. Rate of change of displacement is nothing but, here the displacement equation is y is equals to a into sine of omega t. Here omega, it means what? Omega is the angular frequency which is constant, and a is the amplitude, it is also constant. Maximum displacement is a constant. It means that y is a displacement of the particle which is depends on the time taken. This time, the time period, is depends on the time period, or the time is there. Okay. According to this one, that omega is nothing but what? Omega is equals to what happened? It is 2 pi, frequency is there, that is nu, or it is also known as 2 pi divided by t. It is like, okay, its omega is equals to what? 2 pi nu, or it is nu is nothing but a frequency, that is a reciprocal of time period. So that is 2 pi by t is there. We will write the equation as like this: y is equal to in this equation I will write only x here. X is equal to a into cos of 2 pi divided by t, 2 pi divided by t into tz. Okay, it is t. This then again y is equal to a into sine of 2 pi by t into t. If the initial phase is there, then what happened? Plus of phi. Here also plus of phi. Okay. Then velocity of the particle executing simple harmonic motion. Velocity of a particle executing simple harmonic motion. The next slide, we have to calculate the velocity of the particle by using that displacement equation. That is the displacement equation is here. You can take this one and this one also. Okay, it's a wave. First I will draw the oscillation, the periodic motion of the particle. Just okay. Okay. Next here, velocity as well as the displacement. I will draw both in next class. Okay. First, velocity is nothing but what? It is nothing but the rate of change of the displacement of a particle executing what? Simple harmonic motion. Executing simple harmonic motion is nothing but the velocity. It is called what? It is called velocity. Velocity of simple harmonic motion. It means I'll write that velocity as in a capital, okay, capital V. V is equals to what happened? This is nothing but dy by dt. dy by dt is rate of change of displacement, na? So rate of change of displacement is nothing but d divided by dt. Because the displacement is changing with time. Amplitude and omega both are constant here. A into dt. Then y is equal to what? That y is nothing but the displacement of the particle, that is a into sine of omega t. If it is a certain initial phase, you can take here, it should become 0 here. But I will write this one, this one also. Additional part, any constant, it means the differentiation of any constant is 0, na? Initial phase is also 0. This is called the velocity of the particle. Okay, then we have to differentiate this one. After we can get the velocity of this one. Next, you already know that it's SI unit. It means the velocity SI unit. The SI unit of the velocity is nothing but displacement in terms of meter, and this one is in terms of time, that become what? Meter per second. Its dimension formula is also there. I'll write again here in the straight line. We discussed already here, and again I'll write here. Meter is length is there, then L and T is there -1. Then this is unit of velocity of the principle of motion, and another one is this one. Just your work is just your try one in home, okay? Try in your home, okay? One thing, just differentiate this one. Differentiation of what? A. I'll tell already here. A is a constant, it is an amplitude. Omega is an angular frequency, it is also constant. Both are constant. Right here, A and omega are constants. Constant. But only the variable terms are that displacement of the particle with the time. The time is here, but we are differentiating with respect to time only. Up to here we have to differentiate. Just differentiate this equation. It means differentiate this y with respect to time. We will get the velocity of the particle here. Okay? Just try. This is your homework. Okay? Okay. Thank you.